Okay, let's unpack this. You've seen AI tools evolve at an almost, well, dizzying pace, haven't you? From those initial, often pretty simple chatbots to these incredibly sophisticated systems now. But what's that crucial ingredient, the thing making these AI agents truly smart, truly, human-like in what they can do? Today, we're taking a deep dive into the fascinating world of AI agent memory. We're drawing insights directly from an expert perspective shared by Richmond Alec of MongoDB. Our mission here is to pull out the most important nuggets, the key ideas that will put you in the best spot to understand, maybe even build the next wave of AI applications. Agents that are believable, capable, and importantly, reliable.
Yeah, and what's really fascinating here is that we're moving beyond just simple inputs and outputs, the stateless stuff. We're talking about making AI truly stateful so it actually remembers past interactions. And this fundamentally cuts down the need for constant, painstaking prompt engineering. It lets these agents build genuine, evolving relationships with users. And if you connect this to the bigger picture, where AI is heading, well, it all hinges on one fundamental memory.
That makes so much sense. I mean, we humans don't operate in a vacuum, right? Our past experiences constantly shape how we act now. So, this deep dive will trace that incredible journey from those early chatbots to these new sophisticated agents. We'll explore why memory is just as crucial for AI as it is for, well, for us, for human intelligence. Then we'll dive into the actual mechanisms. How is agent memory managed? We'll even peek into some specific practical applications being built right now. And we'll see how neuroscience is maybe surprisingly informing the future of AI. Here's where it gets really interesting. Looking back just the last couple of years, it feels like AI has just completely transformed. We all remember that explosion, right? LLM powered chatbots like ChatGPT back in, what was it, November 2022. Then things got even more advanced pretty quickly with retrieval augmented generation, RAG, which, as many of you know, gave LLMs access to more domain specific, sort of outside knowledge that led to much more personalized, more accurate responses. But there's been a clear step beyond even that, hasn't there, leading us to AI agents or agentic systems. So, could you walk us through that progression? What really defines an AI agent in this rapidly changing landscape?
That's a great question. And honestly, the definition itself is still kind of fluid. It's not really black and white. It's much more of a spectrum. People often call it agenticity. Think of it maybe like the different levels of self-driving cars, level one, level two. At one end, you might have a minimal agent, maybe just an LLM running in a loop, constantly refining its output. Pretty simple. But at the other end, you have these highly autonomous agents. They can make their own decisions, access loads of tools, and need very little, maybe even no, human prompting.
Right. Okay. So, if it's a spectrum, what are those core things, those defining characteristics that really separate an AI agent from just, say, a really smart program or a very capable chatbot? Like, what's the minimum needed to genuinely call something an agent?
Excellent point. So at its core, an AI agent is basically a computational entity with four key characteristics. First, it needs awareness of its environment through perception. It has to be able to take in information. Second, it needs cognitive abilities, usually through an LLM, so it can reason and process things. Third, it needs the ability to take action through tool use. It has to be able to do stuff in the world, digital or otherwise. But the most important bit, the real differentiator, the one that elevates it beyond a standard chatbot, it has to have some form of memory. Short-term, long-term doesn't matter initially, but some memory. This memory, that's what allows agents to be reflective, interactive, proactive, reactive, truly autonomous. Pretty much all these advanced capabilities we want, the ones that feel intelligent, they fundamentally hinge on memory.
That immediately connects to how we work, doesn't it? If AI and maybe eventually AGI is really meant to mimic or even beat human intelligence, then yeah, memory seems like an absolute must have. But why is it so non-negotiable for the agents we're building right now? What specific problems does memory solve that, I don't know, clever RIE or prompt engineering just can't handle on their own?
Well, the real genius isn't just that it mimics us, although that's definitely a powerful inspiration. It's that memory fundamentally breaks that stateless barrier that held back earlier AI. Old systems treated every single interaction like it was the first time, blank slate. With memory, agents can genuinely learn from every interaction. They build context, they apply past knowledge. They're not just processing isolated commands anymore. Our own intelligence as humans, I mean, it's largely defined by our ability to recall and apply what we know, isn't it? We use this whole orchestra of memory types all the time: short-term, long-term, working memory, semantic, episodic, procedural.
And what's fascinating is how directly that human blueprint can inspire AI. I remember reading something about the cerebellum. How does that fit into what we're building in agents?
Exactly. In your brain, complex motor skills, think about doing a backflip, all that incredible coordination and timing that's largely stored as procedural knowledge. Areas like the cerebellum handle it. It allows for fluid, almost unconscious action. And this isn't just some abstract parallel. That kind of procedural knowledge can actually be mirrored in AI agents. So agent memory, it's really all about the mechanisms we implement to make sure information or states persist in AI applications. It lets agents gather information, turn raw data into useful memory, and then use that memory to decide what to do next. The ultimate goal, like you said earlier, is making them more reliable, believable, and capable.
Okay, so if agents are collecting all this information, the core challenge seems to be managing it effectively, right? So the AI doesn't just get swamped. For the engineers building this, the AI memory engineers, what's involved in that systematic process? Memory management. It can't just be about stuffing everything into a giant context window, surely.
You've absolutely hit the nail on the head there. Memory management for AI isn't just dumping everything into the context window. That's super inefficient and hits limits really fast. No, it's a much more sophisticated, systematic process. It's about organizing and prioritizing information. The goal is to pull in only the most relevant memory for the current task and structure it effectively for the LLM. The core parts of this process, well, they involve generation, storage, retrieval, integration, updating, and importantly, the possibility of deletion or forgetting.
Right. And that point about deletion, that feels a bit counterintuitive. Normally, we want AI to remember everything, don't we? Why would adding a forgetting mechanism actually make an agent, smarter or more effective? Humans don't really delete memories like files, do they? Unless maybe it's trauma.
That's a really interesting parallel to how our own minds work. Humans don't typically just delete memories, like hitting a delete key. Instead, some memories fade over time, or maybe we suppress them, or their relevance just diminishes naturally. So this raises a really important question for AI. Should agents implement some form of forgetting mechanisms? Maybe by deprioritizing or decaying less relevant memories rather than outright deleting them. Givert research papers are actively looking into this right now. The idea is to keep the agent focused and efficient, not bogged down by tons of irrelevant old details. But whether it's deletion or some kind of intelligent fading, the absolutely most crucial component in all of this is retrieval, getting the right memory at the right time.
Okay, so if retrieval is truly the linchpin here, the key to effective AI memory, what kind of infrastructure, what kind of system best supports that kind of sophisticated dynamic process? Where do these memories actually live, and how does the agent get hold of them when needed?
That's exactly where a database like MongoDB becomes just absolutely integral. It's designed to be core to many RAG pipelines already. It provides not just powerful vector search, which is essential for semantic understanding, but also a whole range of other retrieval methods. So when we talk about these new agentic systems, MongoDB often functions as that critical memory provider. It offers a flexible, really robust backbone for these capabilities. Its document data model is incredibly adaptive. It lets AI memory engineers turn all sorts of raw, diverse data into actionable memory, which, again, directly contributes to making those agents believable, capable, reliable. It offers diverse retrieval options, traditional queries, advanced vector search, graph traversals, text search, even geospatial lookups, all in one database. And this flexibility really comes into its own when you start looking at specific types of memory.
That adaptability sounds absolutely key for building truly nuanced, sophisticated agents. You've even developed an open source library, right? Memorize, I think it's called, to demonstrate some of these practical patterns. Could you walk us through a few of the most impactful memory types that people are actually implementing today?
Absolutely. Let's start with something like persona memory. Imagine an AI assistant that actually remembers your preferences, your little quirks, maybe even your evolving needs over weeks or months. So interactions feel less like just a transaction and more like you're talking to a trusted confidant, someone who gets you. That's persona memory. It transforms the user experience from just functional to something truly relational. It helps make AI systems way more believable, more human-like, and helps foster those genuine long-term relationships with users. Then there's toolbox memory. This tackles a really significant practical problem. OpenAI's guidance, for example, suggests you can only put about, say, 10 to 21 tool descriptions, the schemas, in the context window before the LLM starts getting confused. It might start hallucinating tools that don't exist or just forget what it can do. But if you use a database like MongoDB as your toolbox, storing the JSON schemas of all your available tools there, well, you can scale way beyond those limits. You just retrieve the relevant tool description right before you need it, just before hitting the LLM. It makes your agent much more versatile and, frankly, more robust.
Wow, yeah, that's a huge practical leap for what agents can actually do. What about just remembering the conversation itself? That seems pretty fundamental for any intelligent agent.
Precisely. Conversation memory might seem obvious at first glance, just storing the chat history. But we're talking about storing with more useful detail, timestamps, unique IDs for each conversation, maybe even tracking things like recall recency or linking related conversation IDs. This is really an attempt to implement those memory signals, like how recently did we talk about this? How important was it? What was the tone? These signals can then inform those forgetting mechanisms we mentioned. They help the AI prioritize what's relevant right now and not get totally bogged down by every single word ever exchanged. It's a bit like how our own minds filter information. And then there's workflow memory. This one's incredibly important for building robust learning agents. Say your agentic system tries a sequence of steps to achieve a goal, and one of those steps fails. That failure isn't just a dead end, it's actually a learning opportunity. You can store the details of that failure, what was tried, why it failed in your database, in your memory provider like MongoDB. The next time a similar situation comes up, the agent can pull in that memory of the past failure. That informs the LLM. Hey, don't try that specific step again. Or maybe explore these other alternative paths instead. It allows the agent to learn from mistakes.
So it's not just about what the agent can do, but also what it's learned from its past actions, both successes and failures. That's powerful. Beyond these specific types, persona, toolbox, conversation, workflow, are there other kinds of memory being explored? And, with all these different memory solutions popping up, why is having a dedicated memory provider, like you mentioned with MongoDB, still so crucial?
Yeah, absolutely. And many others being explored. Things like episodic memory, remembering specific events, long-term memory, storing core knowledge, agent registry, keeping track of different agents, entity memory, remembering details about specific people, places, things. It's a really active area. And you're right, there are existing tools out there specifically for memory management, things like MEGPT, ME0, SEP. Each has its strengths. But the thing is, there isn't really one single way to solve memory. It's complex, which really highlights why you still need a flexible underlying memory provider. Something like MongoDB lets you build custom, highly effective solutions tailored to the specific needs of your agentic system. You're not locked into one approach. And to really boost these capabilities even further, MongoDB recently acquired a company called Voyage AI. They create some of the absolute best embedding models and re-rankers available today. Now, this is crucial because embedding models help the AI grasp the actual meaning of your data, not just keywords. They convert information into vectors that AI can effectively search and compare. Then, re-rankers act like a super smart filter on top of the search results. They make sure the most relevant information is always surfaced first, pushed to the top, put them together, and they significantly reduce AI hallucination, making things up in both Arvade setups and these more complex agentic systems.
That sounds like a really powerful combination, almost like a 1-2 punch for relevance and accuracy. It seems like a potential game changer for developers. So how will Voyage AI's tech actually be integrated? And what kind of simplification can developers expect, especially with those tricky, complex tasks like chunking strategies?
Yeah, the future integration is definitely very exciting for developers. The plan is to pull Voyage AI's models and re-rankers directly into MongoDB Atlas, the cloud platform. This will simplify a lot of those complex processes like chunking strategies, which is all about how you break down large documents into smaller, manageable, searchable pieces. That can be really fiddly to get right. The goal is to make it much easier for developers to turn their raw data into effective, retrievable memory without having to become deep experts in managing all those underlying complexities themselves.
So, stepping back, what does all this mean for the bigger picture of AI? We've been talking about, architecting intelligence, building these incredible systems, but it does make you wonder, are we trying to reinvent the wheel here? Or is there maybe a blueprint for true intelligence that's already been perfected? Turns out maybe that blueprint is right inside our own heads, and it's been informing AI for decades, perhaps more than we often realize. Think about that compelling story of Hubel and Wiesel. They won a Nobel Prize late 90s, I think, for research they did way back in the 50s and 60s on the visual cortex of cats.
Yes. Their findings were absolutely revolutionary at the time. They discovered that the visual cortex learns things in layers, these different hierarchies of representation. It starts by recognizing simple things like edges, then builds up to contours, and eventually recognizes more abstract shapes. And this isn't just some dusty historical anecdote. That specific research directly inspired and informed the development of convolutional neural networks, CNNs, which are, they're the absolute backbone of almost all modern computer vision. Like, face and object detection. It came directly from studying biology.
That's incredible, isn't it? How a deep dive into biological systems, into how brains work, directly led to fundamental AI breakthroughs. So if we connect that lesson to today, to what we're doing now with agent memory, what's the core message here? Should we keep looking inwards to nature as the ultimate architect of intelligence while building these next-gen agents?
Absolutely. I think it raises a really important question. We are architects of intelligence, yes, but there is arguably a better architect of intelligence out there, nature. The human brain remains the most effective, most adaptable form of intelligence we know. So yes, we can and probably should look inwards much more as we build these agentic systems. That's actually why MongoDB is actively working to bring neuroscientists like Kenneth, who's studied the human brain and memory for over 20 years together with application developers. The idea is to try and mirror how natural intelligence works, learn from it, and hopefully push us closer, maybe incrementally on that path towards AGI. So if we connect all this back to the bigger picture, it becomes pretty clear, I think. True intelligence in AI agents isn't just about raw processing power or having access to vast data lakes. It's fundamentally about how they remember, how they learn from that memory, and how they apply that knowledge effectively. Much like us, really, it's about building in the very mechanisms, the memory structures and retrieval processes that make us intelligent and adaptable in the first place.
You came here to get well-informed quickly, and hopefully you now have a clearer, maybe deeper picture of why memory is truly at the very heart of this next generation of AI agents. It's a field that's moving incredibly fast, as we've discussed, and the insights shared today, especially those parallels to our own cognition, they're likely to be relevant for a long time to come. But here's something to think about as we wrap up. As we get better at architecting these AI memory systems, as we strive more consciously to mimic the human brain, how might our own understanding of human memory itself be transformed by the very act of trying to build it into machines? And what profound, maybe even ethical questions does this raise about the nature of intelligence, both artificial and our own? Keep those powerful ideas in mind. Lots to chew on there as you navigate the rapidly evolving world of AI.